I started that. Evidently I didn't. I guess nobody was in the room, but I thought I started it. I did everything that would have started it, but evidently it didn't get started, or I hit something wrong and it stopped it. I don't know. Sorry, all that I have said so far was not recording, and I don't know why. Please watch that for me. I just happened to notice that was on there. Okay. Now, let's do the next one. This is E. No, yeah, E. So I'm going to have to erase all this ink so I can write E. Here is E. 1, 2, -3, 4. 0, 2, 1, -1. 0, 0, 1, -3. Is that in row echelon form? Why not? Is not a 1. The first, in the second row, okay, you don't have any L0 rows, that's fine. And the first row, the first non-zero entry is a 1, 0 is below it. Second row, there's your problem. The first non-zero entry is not a 1. Okay, to make that in row echelon form, what we would have to do is divide the second row by 2, or multiply by 1/2. Then you'd have a 0, 1, 1/2, -1/2. That would have been then in row echelon form, because the first non-zero entry would have been a 1, 0 below it, and then the third row, the first non-zero entry would be a 1. And all those leading ones step to the right of the previous one of them. Okay? Good deal. And let's do F. F is 0, 1, 0, 5, 0, 0, 1, 3, and 0, 0, 0, 0. Yep. Is that in row echelon form? Yes, it is. It happens to be in row echelon form. You do have a row of all zeros, but it's at the bottom. That's good. Just because you don't have a leading 1 in the first column, that doesn't negate it being there. It just doesn't have one. In other words, what's that? Right, because of that. The thing is, this is a very interesting, whatever that represents. It may represent something, and it may be important, but it couldn't really be a system of equations, because the first variable wouldn't have any value. I mean, or has an infinite value. I mean, it's 0 coefficients. But the first non-zero digit in the first row is a 1, 0 is below it, and the first non-zero entry in the second row is also a 1. Now this one happens to have 0 above and below it, and then the third row is all zeros. So this one is not just in row echelon form, it's in reduced row echelon form. To be reduced row echelon form, all leading ones have zeros above and below. This one hasn't. Of course, this has no leading ones there. This is not in reduced row echelon form, number 1 because of that, number 2 because of that, and that. That, are not zeros as well. So, reduced row echelon form, those leading ones have to have zeros above and below, not just below. All right, and that is row echelon form and reduced row echelon form. Okay. Now, don't have a book, I'm going to, you okay with erasing these? Okay. All right, let's look at Gauss elimination with back substitution. Actually, we've already done this. I don't think I'll write it again. But here's what we do. We write the augmented matrix. Now, what do we mean by augmented matrix? Yeah, it includes the constants on the right. So the augmented matrix is augmented with the coefficient matrix and the constant matrix. Okay, coefficient matrix are in the right order. The first column all representing coefficients of the first variable, second column representing coefficients of the second variable, third column representing coefficients of the third variable, and on and on and on. Okay, each row represents an equation, but the last column represents the constants, whereas you have something of x1, x2, x3, or whatever, and the last is equal to something another. The augmented matrix has one more column for the constants that equation is equal to at the end. Okay? So, right, the augmented matrix of the system of linear equations with each entry, each row representing an equation, each column representing the coefficients of that variable, of the one of the variables, and the last column representing the constants on the other side, the equal side. Okay, number 2, use elementary row operations to rewrite the matrix into row echelon form, and then write the system of linear equations corresponding to the matrix in row echelon form. Use back substitution to find the solution, just like we've done before. Now, sorry. Getting clogged up again. Seems to happen about this time almost every day, even on Mondays and Wednesdays. I'm usually at the end of a calculus class, and it just is like my head closes up. They do have these linear algebra applied here. I don't remember if the first section had one or not. I thought it did, but this one does. It's talking about the GPS system. Global Positioning System, that's what GPS stands for, is a network of 24 satellites originally developed by the U.S. military as a navigational tool. I remember I was in the Navy at the time, and they got what they called satellite navigation. Okay, that was the name they used back then for GPS, satellite navigation. We did all the things we could, plus we could use satellite navigation to help pinpoint where we were. Okay. I'm sure the land troops did the same thing. I don't know what devices they had. Today they would be called GPSs, and I'm sure that's what they were. So I'll let you read about that, but basically you are in the process of what they call it's an application problem based on that. If this is of interest to you, then that could be a paper topic. Doesn't have to be, but how GPS uses linear algebra. So let's move on to example 5. Example 5 is giving you a system of equation, and then rather than doing equation row reduction, we'll write it as a matrix and do matrix row reduction. Okay? So here we have example 5 starts off x2 plus x3 minus 2x4 is equal to negative 3. x1 plus 2x2 minus x3 is equal to 2. Goodness, not only my head clogging up, but my eyes are drying out too. 2x1 and I did, between classes, go and get some water. I thought that was what was causing this kind of stuff, but I did it, but I still feeling just as dehydrated. 4x2 plus x3 minus 3x4 is equal to negative 2. And x1 minus 4x2 minus 7x3 minus x4 is equal to negative 19. Gracious. All right, what's your first step? Say again? Okay, we basically write the matrix. That's what you're suggesting. Okay, rows and columns, that means matrix. What do we put in the matrix? Okay. 0, 1, 1, negative 2, negative 3, isn't it? Yeah. Okay. 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 All right. Now, there is your augmented matrix. What we want to do is get this in row echelon form, because it says use Gaussian elimination with back substitution. So all we need is row echelon form. And I see something now that is really ugly, and that's that negative 7 doesn't look at all like a negative 7. I just looked at it and said, what is that? And then I had to look back and see that was supposed to be a negative 7.
So Gaussian elimination with back substitution is row echelon.
Is getting it into row echelon form. Exactly. What's the first step to get this in row echelon form?
The first leading coefficient should be 1 in the first row.
Okay, and it's not, it's a 0. Well, actually, you're right. The first non-zero entry in the first row is a 1, so that's okay, except it's not in the first position, and the next one has a 1, but it's to the left of this one. That can't be. You need it to the right. So how could we remedy that situation? Yes, flip the first 2 rows. You could flip the first and the fourth row. Why do it? The first 2 flip just as nicely, so let's do that. Okay? So basically, rather than writing, I'm just going to do it like this. Okay? So that produces 1, 2, negative 1, 0, 2. Here's the thing that is so tedious about matrix operations. You have to do a lot of writing over and over and over again. Say the next row is 0, 1, 1, negative 2, negative 3. The next one is 2, 7, no, 2, 4. Why am I not able to read? All right, goodness gracious. 2, 4, 1, negative 3, negative 2. And the fourth row is 1, minus 4, minus 7, minus 1, and minus 19. Goodness, I can't write. Okay. Wow. I'm having trouble seeing. And there, that negative 7, it will just not write well. I get the writing too fast, I guess. I hope I have everything correct. So easy to drop the sign. Okay. What's next?
We need to have zeros under.
Okay, under that leading line. You got a leading line in the first, that's what we wanted. 1 0 below it, but we need that to become a 0. How do we make that happen? What's that? How do we make that 2 become a 0? Using our elementary row operations. Okay. Here's a hint. Use those leading ones. We only have 1 so far. Actually, we have 2, but that's 1 as well, but we're not messing with that yet. Use this leading 1, multiply something by it, but when you add to that, it becomes a 0. Yeah. Negative 2. So negative 2, row 1, plus row 3 is the new row 3. Okay? So we're using the first row, 1, 2, minus 1, 0, 2. We're leaving the second one alone because it's fine. 0, 1, 1, negative 2, negative 3. Okay? Now we operate on that third row. And what does that give us? Sorry?
Negative 2 plus 2 is 0.
0. Very good. Ooh, nice. You worked that, planned that well, didn't you? Okay. Mm-hmm. Okay. You know, I'm afraid my head is clogging up. I need to go clear. I'm sorry about this. I don't know, what, 15, 20 minutes of class? I forgot to turn on screencaster. I had it on, up, and everything, but it just wasn't running. Huh? The screencast-o-matic that records, so the first part of the class won't be on YouTube. Sorry about that. All right. Goodness. We're doing example 5 on page 17 in section 1.2. It gave us a system of equations. We wrote the augmented matrix representing that system, which was the coefficient matrix of the 4 equations, augmented with the constants at the end of the equation. The 5th column was that. And then we started our row reduction. Okay, we wanted a row echelon form so we can do Gauss elimination with back substitution. What we want there is the first non-zero entry in the first row to be a 1, which we had. First non-zero entry in the second row was a 1, but the problem was this 1 was to the left of that 1. And we can't. To have row echelon form, you have to have the leading ones going down and to the right, not down and to the left. So we had to exchange those 2 rows, or we chose to exchange those. That was our first step. Okay? The second step, we got the first non-zero entry here to be a 1. we need zeros below it. We have 1 0 below it. The next step was to get a 0 here. Okay? And then to do that, we decided to multiply the first row by -2, add it to the third row. And that's what this says. And that's what we were doing. And that's when my head clogged up so badly I could hardly talk. So I had to stop and go clear my head. And now it's clogging up again. I don't know what's going on. It may be just the end of the week. I'm run down. I don't know what's happening. So let's continue. It's -2, row 1 plus row 3. So -2 times 1 is -2 plus 2 is 0. Got it. -2 times 2 is -4 plus 4 is 0. Hey, extra bonus there. -2 times -1 is what? Okay, 2 plus 1 is 3. Okay, next. -3. And that was -2 times 0 is 0 plus -3 is -3. Next. -4 minus 2 is what? -6. Got it. Okay. Now, what do we need to do to the fourth row? What do we want to happen there? We want that 1 to be a 0. How do we get this 1 to be a 0? Using our leading 1. Okay, second. Subtract row 1 from row 4. In other words, -row 1 plus row 4 is a 0, 4. So that's what we'll do. Minus row 1 plus row 4. Okay? And what does that give us? 0. Okay. Negative row 1.
Oh, negative row 1.
Yeah.
-6.
Second?
-6.
-6. Perfect. Next.
What's that?
That's a 7.
That's a 7.
I've had so much trouble writing that 7. It's ridiculous. Okay. -6. Got it. Next. -1. Next. Ew. -21. All right. So let's go back and review. You got a 1 here, just what we want. 0 is below it, just what we want. First non-zero entry in the second row is a 1. You got 1 0 below it. What's going to be our next step? Okay, we can do that ultimately, but let's take care of that -6 first. Okay? And yeah, you're absolutely right. That's going to be our next step. In fact, we can go on and do it. Why not? So let's do that. Row 3 divided by 3. That's going to give us a leading 1 there. Why not do it? Okay? But then at the same time, let's do what?
3R1.
Okay? And we're not doing R1 anymore because we've got all these right like we want. Next thing we want is to get this to be a 0. Using the leading 1 here. So how do we do that? Yeah, 6 times row 2 plus row 4. That's it. 6 row 2 plus row 4. All right. Let's see if we can squeeze this in over here. It's going to be crowded, but let's go. We're not using row 1, so let's write it down. 1, 2, -1, 0, 2. All right. We're using row 2, so we're not changing it. 0, 1, 1, -2, -3. Let's do what you suggested to do to row 3. Since we're there, that will be a 0, 0, 1, negative 1, negative 2. Perfect. Next, this is what we're shooting for here.
0.
Yep. Okay.
0.
Yeah. 0, 0.
Another 0.
Another 0.
Plus, negative 19.
Isn't it more like 13?
Yeah.
Huh?
Yeah, negative 13.
Negative 13. Okay.
Negative 39.
Negative 39. Ooh, not liking that, are we? Okay. Now, I don't think I can squeeze it in at the bottom. So I think what I'll do is go up to the top. I sort of want to leave my original equation there. So I'm going to go up here and clear all these out. We've already used that, done it. Hopefully I didn't make a stupid mistake and I won't have to try to reproduce it. If I do, I'll say I'll leave that to the student. Okay. What does this? Okay, let's see. Do a quick review. All right. We've got a 1 here, 0 is below it. Fantastic. All right. A 1, leading 1 here, 0 is below it. It's to the right of that. Fantastic. A leading 1 here, 0 below it. To the right of that. Fantastic. What do we need that last row to do? How do we make that happen? Absolutely. Divide by negative 13. So row 4 divided by negative 13 becomes a new row 4. So now we have a 1, 2, minus 1, 0, 2, 0, 1, 1, negative 2, negative 3, 0, 0, 1, minus 1, minus 2, and when we do the last step, that will become a 0, 0, 0, 1. What? What is that? Oh. Those black boxes slow you down, though. What's that? Positive 3. I can't talk. We now have it in row echelon form. What? I'm so sorry. I think I'm going to need some more room, so I think I'm going to take out. I think I'm going to take out all this. Okay, sorry about this, but it just gets so crowded if it's all still there. Leave that last one?
Yeah, hold on. Yeah, you can just erase that. I'll be done with that at once.
Okay. All right. I'll go back and put my, I'm sorry I didn't know. Okay. You got enough? Huh?
If you want to, you can erase the next.
Next one too? Okay. I don't have to, but if you don't need it, I'll erase it. But you're going to use that last one, right? Okay. All right. At this point, you know something. What is that something you know? Say again? It's not really a Z, that's an X4.
Oh, yeah, that's right.
X4 is equal to 3. You know that. There it is. So X4, I'm going to write it here. X4 is equal to 3. We know that. So what can we do now? The one above it is? X3. This third row here has 0x1, 0x2. You have x3 minus x4 is equal to negative 2. That's what that stands for, right? Okay? Strange that negative 2 is still what it is. We never changed that, did we? Okay? Now, but we know what x4 is. So x3 minus 3 is equal to negative 2. So what do we do? Yeah, add 3 to both sides, and you get x3 is equal to 1. Okay? Because those go to 0. So x3 is equal to 1. Okay? Now what can we do? Go to the next one, and what do you get? x2 plus x3, which is 1. Okay, I forgot to write it down. So I'm just going to put 1 minus 2 times x4, which was 3, right? And that's equal to negative 3. All right? Let's see what that gives us. x2 plus 1 minus 6 is equal to negative 3. This would be x2 minus 5 is equal to negative 3. So that tells us x2. What do we do? Add 5 to both sides, and that gives us x2 is equal to positive 2. So x2 is positive 2. And finally, if we had room to do it, can I erase that last one? Okay.
I want to make sure I'm getting this.
What's that?
I said I want to make sure I'm getting this. So the next thing we do is x1
x1
plus x1 plus 2 times 1.
x2.
So yeah, x1 plus x2.
Okay, now it's 2 times x2. This is saying x1 plus 2 times x2 minus 1 times x3 plus 0 x4 is equal to 2. Well, your x2 is 2. So it's 2 times 2. So that'll be 2 times 2 minus
x3,
which is
1.
1. I'm not even going to put it in parentheses. I'm just going to put 1. Okay, I started to put it in parentheses, but why not? It's just minus 1. Okay? Yeah, so leave that off. Is equal to 2. Remember, that's where your equal sign goes. In the old days, I used to do this. I put a dotted line here to represent the equal signs. That's equal to 2. Okay? Now let's solve that one. Be x1 plus 4 minus 1 equal 2. That would be x1 all right, so x1 equals negative 1. All right, let's see what the book got. x1 equals negative 1, good for them. x2 is equal to 2, excellent for them. x3 is equal to 1, really good for them. And x4 equals 3, boy, they're sharp, aren't they? All right. That's called back substitution. You get the answer for the last one, and then you start back substituting one row at a time, calculate the next and the next and the next. There you go. That's when you have one and only one solution. You won't always have that case, but this one you did. And what you could do if you didn't trust yourself, which hopefully you do, but actually it's a good idea if you have time, just go back and plug it in. plug it in. It'd be 2 plus 1 is 3 minus 6 is negative 3. Yeah, that works. This will be minus 1 plus 4 minus 1. Minus 1 plus 4 is 3 minus 1 again would be 2. Sure enough, that works. This would be a minus 2 plus 8. That would be a plus 6. Plus 1 would be a plus 7. Minus 9 would be a negative 2. That works. And then a negative 1 minus 4, that would be minus 5. No, I'm sorry. Minus 1 minus 8, that would be minus 9. Minus 7 would be minus 16. Minus 3 is minus 19. So that works too. Doesn't hurt to check your answers, and usually it doesn't take too long. So that was example 5. All right. Any questions? Got it? Okay. Can I erase? All right. We love these systems of equations, don't we? So much they're going to give us another one. Here's one. X1 minus X2 plus 2X3 is equal to 4. Wow, this has one fewer, doesn't it? Should be easier then, right? X1 plus X3 is equal to 6. 2X1 minus 3X2 plus 5X3 is equal to 4. And 3X1 plus 2X2 minus X3 is equal to 1. What would be your first step? Yeah, make a matrix, and that would be 4. Got it. Next. Okay. Okay, that's right. Okay, 1, 0, 1, 6. Wait. This thing gets all messed up. Okay, it did it. Okay. 2. Second. And that 6 I had there just disappeared. So let me write it again. Okay, next. 5, 4, 3, 2, negative 1, 1. All right. What's the first thing you want to be true about that matrix? First non-zero entry is a 1. It is. Fantastic. We're happy. What do you want to happen next? The first entry in the second, in other words, every entry under that leading one in the top row, you want all those to be zeros. So how do we make that first one, the 1 in the second row, become a 0? Second, negative row 1 plus row 2. Is that what you said? Okay. So this becomes, we're using the top row, so write it down, 1 minus 1, 2, 4. What's our new second row? 0. 1, that's nice. Second, negative 1, yeah. 2, okay, nice. Okay, what do we want to happen next? How do we make that happen? First row by what? By negative 2. The opposite. Okay, minus 2 row 1 plus row 3. Okay, that should do it. What does that give us? Zero. Is it?
No, that's 2.
What's again? -1. You see why? Okay, it's -2 times row, let's see which are, yeah, this one right here, row 1, that would be a +2, I'm on the wrong line, sorry about that. +2 minus 3 would be a -1. All right. Okay. All right. Next. So that's it again. The 5 becomes a 1. Is that what you said?
Yes, sir.
Okay. Yeah. Yeah. Okay. Because it would be -4 plus 5 is +1. Okay. -4. Perfect. What's the next thing we want to happen?
The last entry becomes 0.
That 3 becomes a 0. How do we make that happen?
-3 R1 plus R4.
You got it. And what does that give us?
0.
0.
That's going to give you a 6.
Is it a 6?
No. That's going to give you a 1.
Is it a 1?
No, 3.
Okay. Is it a 3? Is 3 plus 2 is?
That's going to give you a 5.
It's what?
A 5.
5. That's a 5. Okay. Next.
That's going to give you a
-7. It looks more like a 7. Okay. And then -11. Oh, those are fun looking numbers, aren't they? Okay. What's the next thing you want to happen? Let's just review. You want the first non-zero entry in the first row to be a 1. It is. Zeros below it. They are. Next.
The next one, it should be 0.
First non-zero entry in the second row to be a 1. It is. It's to the right of the previous leading 1. And now what do we want to happen? 0 underneath it. So that -1 becomes a 1. How do we make that happen? Say again? No. To get that. Oh, yeah, just add. Row 2 plus row 3. That should do it for us. Okay? So this becomes, we're not using the first one, so that's 1 minus 1, 2, 4. Okay? Yeah, wouldn't that adding a +1 to -1 becomes a 0, right? So the second row stays because we're using it, 0, 1, -1, 2. Okay? And then we're adding the second row to the third row, and it becomes 0, 0, 0, -2. Okay? I think we can right there stop and call a timeout, can't we? What does this sentence tell us right here? 0x1 plus 0x2. Okay, what does those add to? Yeah, and what does 0 plus 0 plus 0 add to? -2? Really? That's the last time you saw that happen. 0 plus 0 plus 0 equals -2? It can happen. Second? No, you can't do anything to it. 0 plus 0 plus 0 can never equal -2. No solution. There's no way you'll get this matrix to work. We didn't even have to mess with the next one. This can never be true. 0 plus 0 plus 0 cannot equal -2. Ever. Ever. Okay? So you stop right there. This is one of those good ones. Stop right there, lay it down, say, can't happen. Okay? There's no reason to really take it any further. Okay? They did. No, they just wrote down that last thing, but then they wrote down and filled in the gap and got 0 equal -2. No, 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 not possible. That system of equations has no solution whatsoever. All right. Okay? Do you think we can squeeze one more in or not?
But, okay, so we was talking about all zeros earlier.
Yeah.
That'll give you
That would be okay. Yeah. 0 plus 0 plus 0. Okay. But now, remember earlier we weren't talking about systems of equations. Those are just matrices in row echelon form. Then you get that row of zeros at the bottom. This happens to be, if this was just a matrix and didn't represent a system of equations, yeah, we could keep going. No problem there. In fact, when we went to the next one, we would multiply the second row by -5, add it to the bottom row and stuff. And as long as this doesn't represent a system of equations, you can keep doing, and you could probably get it. You'll probably have to fit, yeah. Do whatever it takes, yeah. But this represents the system of equations. So this reduced form, which is equivalent to that form, says 0x1 plus 0x2 plus 0x3 is equal to -2. That cannot happen. So as soon as you see that, if this represents a system of equations, and you get all zeros but the last, that means 0 is equal to that next one. No, 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 no. It can't be. So you say no solution. And that's what a no solution problem looks like. Okay. Still think we have time for another one? Huh? 3 minutes. You think we can do one of these in 3 minutes? Okay, let's try it. All right. If we go over a little bit, that's okay because we got started late and I had to take a break. Okay? Now we're talking about Gauss-Jordan elimination. Okay? What that means is, huh?
I said you're going to switch it up.
Yeah. What that means is you now don't just do row echelon form, you do reduced row echelon form. And what was the difference in row echelon form? I wish we had that last one back up there. In reduced row echelon form, you have zeros above the leading ones as well as below. So it's a little more work on the front end, but then you don't have to do back substitution.
That's when you have. That's when you have ones going straight all the way down and then zeros everywhere else.
Basically, that would be reduced row echelon form too. You may not have quite that description every time, but that's the general idea. Yeah. Okay. So I think that's probably where we're going to start next time because this is it's a few more steps to it. So we will begin next time with Gauss-Jordan elimination. We'll erase that one. And homework exercises here. Okay, sorry we didn't get any further than we did. Do any of the odds 1 through 5. Do 7 and or 9, either 7 or 9 or both. Do any of the odds 11 through 17. Do any of the odds 19 to 23. And then do any of the odds 25 through 37. And it says you can either use Gauss elimination, which is what we were doing with back substitution, or Gauss-Jordan elimination without back substitution. We haven't done the second part, so any of those you do, just do Gauss elimination and back substitute. Okay, now, a little bit of a timeout here. I was told by a student in my first class, and they use a book by the same author, Ron Larson, that now they have an app for CalcJack.com. So you, on the phone, there is an app you can go to. So you don't have to be at a computer to check your answers and see how it's done. You can actually do it on an app. Okay? Now, that was in the pre-calculus algebra and trig book. I assume, just this assumption here, that works for elementary linear algebra as well. Now, neither one of you got a book yet? Okay. Huh?
I should have it.
Okay. I was trying to think. I think this book has come out with a new edition, but I didn't require y'all to get that if you're happy with the other one. I didn't know they had a new edition. I don't have a new edition, so I've been teaching from this one. Most of the time, there's hardly any change. Now, that app may only go with the new edition, so be sure you check your problem as well as say, that doesn't look anything like what I have. Check your problem. It may be it's a new edition, and some of the problems may be changed a little bit. Most of the time, they have not, but occasionally that might happen. So if you're having difficulty, please check and make sure you have the right edition. That the app is referring to this edition, not the previous, the next edition. Okay? All right, good deal. Now, there's one more thing. It's kind of a good news, bad news situation. Okay? The bad news is next Monday's a holiday. There's no school. Sorry about that. The good news, it doesn't affect this class any. We don't lose a class. All right, good deal. I thought we'd be on Tuesday, Thursday. Okay, so good deal. Any questions? All right.